Good afternoon. Wow, it does not bigger. I hope everybody is awake. We have a lot of material. The lunch was amazing. I think we'll have to say thank you. But let's start. We are here. So the obligatory slide about us. I'm Efim, Chief Architect of LivePerson here in Israel, and Itai, my colleague, is a System Architect, Frontend and Mobile. And we're going to talk about basically a journey we've taken over the last 2 years in building the current web application that we have. If you want to really see it afterwards, you can look in our booth. I'm going to skip over one slide very, very quickly. Standard SPA, we're not going to really talk what it is. You all know the server is responsible for security and data. The client side is responsible for rendering. There are multiple meetups and everything. And we very quickly understood that this is the direction that we want to do and build an SPA. However, when we started looking at the requirements that our business came up with, we saw that it's going to be very tough. And the requirements that came were the application should run for at least 12 hours without crashing, and normally 24. The application should be very, very contextual. Depending on where you are in the application, things should change. It should be one portal for all LivePerson customers to enter and manage their account and interact with the visitors of the site. And that means that it's a mix and match of both real-time and management interfaces. And normally they're written a little bit differently, but here we needed to put them all inside. Being an existing company, even though we're building a project from scratch, we do have a lot of what we call legacy code, and you cannot just throw it out. You want to host it, you want to still reuse it as much as possible. We also had a challenge of projected growth of developers. And originally when we began, we were about 8 to 10 developers on UI, or client side nowadays we say. Now we've grown to 45, working on the same project. It's actually tougher than it sounds. So we'll talk a little bit about that. We also were required by product to maintain maximum UX flexibility, while maintaining the common look and feel, and it became also one of the challenges. Now, instead of trying to explain the product, and I'm not a product person, I will kind of flip through a few screenshots and try to explain what's going on very quickly so you get some context. Here is the main real-time view of the visitors visiting our customer's website. It's updated almost in real time, with about 5-second delay, and that's what we call a web agent view. You see all your visitors and you can interact. Here is a screenshot of a web agent having a chat with one of his visitors. There are multiple parts to this page, and one of them is the queue that you manage. It's real time, it's being updated in real time as it comes, and things pop in and out. This is the data bar. This is contextual. Depending where you are in the application, the data bar actually changes to the relevant view for you. So if you are now within that visitor, you'll see one information. If you're in another part, you'll see completely different information. This is the chat, real-time chat. You all can do simple chats. This is the information about the visitor on that page. And more canned answers, what we call predefined answers for that visitor that our system chose in particular. In addition, another level of complexity is embedding others. We've actually acquired a co-browsing company, and they have a product, it's great, and we want to embed it inside the application. That poses some risks and some challenges that we're going to talk about how to solve. And one more about the data bar. The data bar, as you saw, is just few numbers. However, if you pull it down, the whole reporting system is wrapped into this, and again, it's contextual. So that kind of a real-time part of application, or at least an example of a subset. Here is the configuration part. Again, one small example. We configure digital engagement to send based on various rules. And we've developed what you see is what you get editor for us that you can drag, drop, add, remove, and configure. So here is an example. We're changing a picture to somebody I think you all know. And apparently we had to give a URL, and it's a known URL, and it's in black and white. But we want to change also the background, so we change it. From the moment you save it, it takes up to a minute to propagate throughout our system, and it starts being displayed to relevant visitors. Now I'm going to switch kind of from the product mode to a technical one. When we looked at all of that, we also have another fact in our company. We're a microservice-oriented architecture on the back end. So we have about, today we use 15 plus APIs on the back end to draw and render and fetch data and provide various functionality in the UI. In our system, each microservice is a complete microservice stack, meaning it has its own domain, it has its own web tier, app tier, with everything that it brings. Some of the microservices that I exposed assume polling, REST polling. We are still in that world. Some of the services can be done over WebSockets, and each one, as I said, is its own domain. Now, when we looked at all of that together, we took the business requirements, the screenshots or the initial UX, we actually came back to this. And I have a story. I actually personally argued with the CEO of the company that it will be impossible to build it in the browser 2 years ago. I'm glad I've proved myself wrong, because in the end the conversation ended by saying, I challenge you, and I said I accept the challenge, and we've built it. Now, few challenges that we raised at that point, I mentioned some of them, but just to go over a list, is it's a huge scope. At that point, when we got all the requirements in the new business model, we were feeling a little bit overwhelmed because it's a huge scope, and in our experience with product, they don't really know exactly where they want to be in 2 years. That's the idea where they want to, in the direction, but we have to be a little bit flexible. We're microservice-based, and that means cross-domain communications. We have scale problems with dev teams, and even, I would call it still scale, but over time, what Sergey mentioned, you somehow always end up in a soup. In all previous mini attempts, in all the other things, you start with a great idea, single-page application, and within 6 months in a soup that you can't maintain, especially with 45 developers. We wanted to design it and architect it for longevity and modularity, which was very, very important, especially for a company. An enterprise-grade company does not create a product for 1 year. That's at least 5-year lifetime, at least. The last UI we've created was with a company for 8 years. So we have to have some flexibility in it. So how did we do it? I'm a big fan of a game, Command and Conquer, and we actually used a similar slogan. We basically said divide and conquer. And immediately we understood when we looked at the problem that the first division line is the main application, what we call, or we call it framework, and mini apps around it. So immediately we split the problem into the main app and things that you need to do, and distinct mini applications. So there are quite a few that we chose. We divided it into, and it's not the full list, but you saw the web agent, you saw the configuration, we call it campaign, and so on and so on, and we can expand and add more modules or mini applications into that. And then we looked at the framework and said which concerns should the framework deal with. So we came up with a list. The one which was a business requirement for us is managing the context of the whole application, because mini applications are supposed to be contextual. The second one is communicating with the server. Again, cross-domain with all its minuses and limitations. Itai is going to cover that more. Mini application management. Those mini applications have a life cycle. They have to be loaded, unloaded. Also, Itai will go into more details. One of the ways we solved the common UX and look and feel is by developing our own component library. We have today, I think, around 40 components that we've developed, and ideally, it doesn't happen always, but our UX people just pick and choose the component they need, and they don't have to produce pixel-perfect UX screens for us. And the last one, which is obviously the routing. So this was our division, and then we understood that we are okay with the framework. We actually took exactly the same principles and applied them to every mini app. The mini apps don't deal with exactly the same concerns, but the same philosophy, even to the level of file structure and all the kind of pre-agreed naming conventions and all the rest applies. You feel as a developer at home both dealing with the framework and within the mini app. I think that was the biggest breakthrough in our kind of ability to handle that problem. We divided it into separate business pieces and conquered each one separately. The next one was the tech stack. That was very tough. I think that was very emotional. I've managed a lot of discussions of why didn't we choose A versus B versus C, especially in MV star providers. A little bit less in other tools, but it's almost like a religious war. We're not going to go in. I'll tell you what we've chosen, and if you want to argue, we are available at our booth, but not here. There are a lot of tools, tons of tools. There is almost like a new technology every day. You wake up every day, you see on Twitter there is a new cool technology, and you say, wow, why didn't they choose it? We basically did a different approach. We came back and said, let's put some ground rules. What kind of technologies would we want to choose? And immediately, it's also kind of influenced by the way NPM works and tries to influence it. We wanted and gave preference to tools and technologies which are small, do one thing or one problem, and they're composable. Not everything is, and it helps you to sub-filter the list. We also chose not to choose opinionated technologies. For us, that was a very, very good thing, because if the technology is not opinionated, it's easier or very easy, but at least doable to replace it over time. Now, actually in our discussions, we came on the whiteboard with a list of technologies, and we looked at it, and a lot of people forget the last step. You step back, you look at the list, and you see if it all works together. For us, we had to do some substitutions and some adjustments, but we came to a stack which works for us. We chose Backbone, Marionette, Mustache, and others. There are tons of technologies. There are tons of small libraries that we use and for helper functions. I'm going to stop at this point and pass on to Itai. He's going to go a little bit into more detail for a lot of concerns that I raised, and then we'll summarize.
So, picking up from where Efim left off, one of the problems that we had, as he described, is that we have microservices. And it's not just microservices, they're cross-domain microservices. Each domain solves a different problem, and we need to communicate with all of them from the same browser. So what we did is we wrote a communication library called Transporter. That communication library answers the cross-domain problem. It solves it on the client almost completely. You need a little iframe for it, but it solves it almost completely on the client. And it allows for XHR behavior, which is something that's very important if you're using Backbone. Backbone depends on the REST model, and if we're still using the REST model cross-domain, then it's just transparent for all the CRUD behavior that you want. Now, another thing that we came across when doing all of these requests is that it's kind of heavy on the browser over time. And we came up with another technology for that that's called Batchler, which is something that we've open sourced and you can look up at GitHub. But basically what it does is allow us to batch a lot of requests and get one response for them instead of dispersing too many requests. Another problem that we talked about is how do we do internal communication in the application. So one of them, as Efim described, is building a top-level application and having many applications. So the top-level application is, of course, a manager or a mediator of sorts. And what it does is it helps you manage the parent-to-child communication. There are a couple ways that it does that. One of them is that it allows publishing events or sending request-response behavior to the parent and seeing what's supposed to happen as a response. Now, I have a little saying that one of our lead developers on the project always used, and he said, a child can always scream up to the parent, do this or do that, but the parent really has to decide what's supposed to be done and how it's supposed to be done. So that's kind of the main basis for the manager application or the mediator. It sees if it has the data in memory or it needs to make a request, if it has an instance in memory or it needs to create one, if it needs to fetch new information or build a new view for that child. Internal communication is actually very simple. It's event-based and based on backbone and Mariana typical views. But we have child-to-child communications. So for example, if you have an application that's in user management and it suddenly wants a profile picture of another company, then it needs to send that request across. Now obviously, children should not know each other in a modular application. So we also use the parent for that. It just proxies the request and then answers when it has a response for it. The last thing I want to talk about is child-to-friend communication. As Efim noted, we also host other applications inside of our application. Now we want to do that as seamless as possible because if we have a model and you want to bind to its events or you want to bind to events that are listening on the application inside of a different domain or another application, you need help with that. So we built something that's called Kronos, and we'll be open sourcing it soon, and we have to talk about it in the near future. But what it does is it allows you to listen to events from another domain in an iframe on our application. Next part, components. One of the things is, if you build complicated UI, you don't want to rebuild it every time, right? You just want to build that specific list or that specific drop-down or that specific autocomplete, but then you want to compose it into more complicated components. So the mini apps are sort of modules within themselves. As Efim noted, they're separate paths that have the whole structure of the file system. And they behave as components that are loaded into the main view, which is what the application manages. We have composite views inside of those, which are made of the components that we built before. And of course, lastly, we have the ability to add the external applications into that whole situation and allow the clear communication. View management is complicated in a single page application, and if you're hosting many applications, that means that they all assume that they're running on the page and they have all the real estate and the ability to work seamlessly without taking consideration to how much DOM am I loading, how much DOM am I using, how much events am I binding for. So for view management, those were two big problems. One of them was, of course, CSS, which, as we talked about before, was actually presented here before, can get messy. You can override different classes, you can override different visualization. And we chose SAS and Compass to help us with that problem, as well as namespacing for each specific mini application to make sure that its specific style is noted under that namespace only. The second thing is DOM. And with DOM, we had a lot of help from the external libraries that we used. We used Marionette and we used jQuery. Despite jQuery not being so popular these days, it still solves a great problem of not having to unbind every time you want to remove elements from the DOM and add elements to the DOM. So that solved the DOM problem. Next thing is we have ongoing challenges. This is a 2-year application. As Efim noted, we have a really big team working on that application. It keeps evolving in terms of features, in terms of additions, and the requirements aren't stopping because this is something that we keep pushing to our enterprise customers. One of those things in those challenges is performance. So performance tends to degrade over time unless you really keep a good eye on it. So the first thing we did is we did real user metrics. This means that the real-time application logs data of what the performance metrics are at a specific time for each user, and it sends it to a centralized server for us. And then we can look at that data and analyze what's going wrong and what's going right. So here's a sample for a web tier, all the way from the client and back, and how it's performing. It's performing at about 300 milliseconds round trip, which isn't that bad. Another sample is this one. And this one was a visitor feed. I don't know if you saw before, the really big list with all of the current visitors on the site. And as you can see, this is really erratic behavior. This is not something that you can keep pushing in this way. So this monitoring allows us to optimize and look where we have problems without needing to analyze only the back end, but also the front end experience. We also apply similar techniques to analyzing the responsiveness of the UI and watching how the memory consumption is going on the browser. When you have something that runs for 8 to 24 hours, the assumption is you're not going to kill the browser for it. And the assumption is you also don't know your environments. So we monitor that closely. Last thing is, of course, code. You have 45 people working on code, it can get messy. So the first solution we have is the people. You can solve many things with tools, and you can solve and apply very rigid patterns to what you allow and what you don't allow in your application, and include or exclude everything that you want. But in the end, it comes down to the people that you have, and you have to have the correct places, people in the correct places. So what we do is we have key people in each one of the teams, which are people that we keep growing and we keep teaching. And the idea is that you need to propagate that throughout the whole development team. Make sure everyone has code review progress, and that makes sense. Make sure that everyone speaks the same language when writing the code. So when you move teams, it doesn't look like there's a new monster here that you haven't seen before. And it's something that we really, really push at LivePerson. Lastly, of course, is tools, because there's no getting along in this world without tools. So we've chosen a lot of tools, and I'm sure all of you know that today, the amount of tools that you can add to your solution are seriously incredible. One of the biggest things that helped us was the move to GitHub, and of course using NPM. It allowed us to keep the modularity at an even finer level and have inclusions from different parts of the organization be also part of the main project. So for example, the Cronus project that I was talking about, we don't consume it directly inside of our project as part of the project, but it's external, and we can build it into the build process. We of course have inspection tools like JSHint, and we rely on SAS Compass, and of course unit testing and system testing. We rely heavily on Blanket and Mocha these days. I'm going to hand it back to Efim to talk a little bit about how we sum this up.
So we've talked a lot about how we build and things, but just to close, I'd like to share with you the takeaways that hopefully will be useful to you and will not take as much time as it took us to reach some of them. So the first one, which is very important, is take your business problem. That's not what you're writing normally. It's the end product. It's what the business tells you they need. That's not how you're going to write it. And take the business problem and define your own problem space. Your own problem space in our, for example, the business said, well, we want a web agent, we want configuration, we want that. We actually looked at that, stepped back and said, well, let's call the web agent a mini app, let's call the configuration a mini app, let's call the data reporting a mini app, and that suddenly made the problem manageable. And that's very, very important. A lot of people immediately assume whatever product drew on the UX today, actually, that's what they need to build. In a lot of cases, this is a back and forward because it's a commitment by two parties. And you don't want to find out 3 months down the road that the product says, no, I didn't need that, I just drew it because it was easy to visualize, but now I want it differently, and your whole design is wrong. So the basic structure of your application has to be a commitment of both parties. And the usual, don't yet start coding afterward. Plan ahead. Now the biggest advice I can tell you is be very, very clear what you're building. Don't lie to yourself. It is okay to build a POC to go out and throw it out in 6 months. It's great. You're going to do it in a week or a weekend, and then it's not going to be very secure probably, but it will get the point across. You will try the waters with the product. You will take it all the way forward. As soon as you have the first 10, 20 customers, it is okay to throw it out and start again. It does cost a lot more to develop things properly. You have to plan for scale in everything. Scale in the traffic you want to support, even the lists. Your API returns 500 items. You probably cannot render it without server-side paging, or 10,000 items. But you can begin with 50. For maintainability, really plan ahead and be ready to pay the price. Nothing in this life is free, so if you want maintainability on your project, you have to pay. It comes in cost of development. However, if you are planning for a team of 3 forever, don't plan in very elaborate processes around the development. We had to plan for a team, I hope we reach 100, but and our current approach will scale to that. Plan for maintainability. Always put things, before you choose a technology, choose how you're going to maintain it. Before you make a design decision, decide how is it going to be maintainable or not. And only at that point do architecture and design. We use divide and conquer. You can use whatever it works. I think the one advice and tip I can give you, very clearly define roles and responsibility of each module. This is so basic, but people normally define and then they forget what they've defined, and over time you get into a soup. Divide and conquer and then repeat exactly as I said. And tooling. Itai talked a lot about tooling. You can never have enough tools, you can have too many. So find your balance. Don't over-tool, but also don't under-tool. The one thing that I think, to avoid religious wars about various frameworks, do not believe the hype. It might be that the technology is not actually solving the problem you have. In our case, our business is relatively unique or different enough that a lot of technologies just don't apply. They're cool technologies. I play with them in my spare time, abundant, and but they're not matching your problem. Don't lie, at least to yourself, because the hype has this power behind it to follow. That's fine. Don't mix fun and business. Think big in everything. Try to foresee what you're doing, but start small. It applies to the team. If you're starting such a project from scratch, start with a small team. 3-4 people maximum. The best people you have, put them in, lay in the groundwork, because on that groundwork your whole application will stand. It also means don't implement everything. Even if you architect it for the problems, you don't have to solve them today. You can put things into the architecture that is not implemented. For us, our mini applications, the first release of the application was, all of them were bundled into one big file and downloaded to the browser. The file was like 600K zipped. And we knew that we will have to do lazy loading of mini applications. We put this in the architecture, we put an empty placeholder, and we didn't implement that. At one point, we had to go back and spend a couple of weeks on implementing that properly. But if you don't plan for it, suddenly it's a big and very drawn out process to replace. One more thing, test, and test. Measure. Real user monitoring can be very expensive or can be very cheap. We didn't buy a product from anybody. We put a stupid Node.js server that we report metrics. We put an open source database that we keep data for very short time, because after a while its value goes really down, and we slap Grafana on it. You're done. That's it. It took us about a weekend and a half to set it all up, and if the metrics goes down, great, fine. Not big a loss for a short time. But do measure. It's invaluable for, just to quote one of the initial presentation, to piss off the gods of the backend, because one of the screens that Itai showed was a badly behaving backend server, but also to see what's going on, and you find surprising value in it. You see not only how well it performs, but which pieces are used the most or the least in your application. And with that, I think we're done. Thank you.